morning, everyone, and thanks for IoTSF for having me. I'm Shahram Mossayebi, CEO, co-founder of Crypto Quantique. Just got promoted this morning. And I'm just going to tell you how we see the IoT security evolving in coming years. Okay, here we go. So just a little bit about Crypto Quantique. We are based in London. We are an IoT security company. And essentially, we're trying to solve the very basic problems around connected devices, which are trusting the device and trusting the software that runs inside the device. And we're providing those things via two different products. One is the physical unclonable functions, which we have a semiconductor IP, licensing it to semiconductor companies. Our PUF uses quantum tunneling at silicon level for the first time in the world to achieve the security effects that we're looking for. And then we have a software platform which basically take advantage of a root of trust inside the hardware in order to build the trust chain from the chip all the way to the cloud, providing services such as secure provisioning, identity management, and then connectivity to cloud services and secure firmware update over the air, etc. If I'm asking you, if someone asks you how to hack a casino, what's the first thing pops to your head? Oh, well done. You're all well read. So a couple of years ago, there was this casino in Las Vegas which got hacked, and the way they got to it was hacking a thermometer inside a fish tank in the lobby of the casino, which was pretty much one of the first kind of scalable hack in around IoT devices, but also having a big effect on stealing a lot of data, etc. And that basically shows you the importance of any connected device, securing any connected device, regardless of what functionality they're providing or how expensive they are, as a matter of fact. And moving forward, how would you hack a casino in a metaverse world? Think about that. We'll get back to this. From IoT security, we have come a long way from the time that in 2015, I think IoTSF published the IoT security guidelines. A lot has happened. We've made a lot of progress as an ecosystem, as a whole supply chain team, basically. And we are at this stage that security is not being ignored, funny enough, on the supply chain especially. So when you talk to a lot of people on the ground, you've been seeing a lot of IoT security talks on the internet. But when you were actually talking with manufacturers and players on the supply chain, they were still not that receptive to implementing security the way that experts were looking at how to do security. But that has changed in the past couple of years, and we see a momentum on security being taken very seriously on the supply chain. There are multiple reasons around it, from, for instance, pandemic moved people to connect more devices, the cost, the economical cost of cybercrime becoming more and more kind of evident. And then also there are regulations that the governments now are pushing for more rigorous security assessment on anything that is connected. It's hard to do IoT security, though, because the supply chain is very complex. There are many moving parts, and security means different things to each one of them. But as an end user, essentially, you need to have this chain of trust that essentially means anyone, wherever they are, they should have done their security bit properly. So then you, as the end user, or whether you're an enterprise or a consumer, be able to trust the device and do bits with the device in a secure manner. And this is not an easy thing to do. Essentially, if any of these players don't do their job right, this chain will break and can be compromised. And that makes it very, very hard to achieve this chain of trust. And the essence of this chain of trust is identity. There are obviously many things that needs to be done from the foundational level. So for instance, your chip needs to have a root of trust. At the hardware level, you need to have SBOM, you need to have secure development. This morning, we a little bit touched on Cherry, for instance, which is a really interesting technology that can help a lot with memory management and reduces the risk at that level, at the device level. But at the same time, there are other bits that needs to be done. The essence of building this chain at the end of the day is the identity of the devices. If there are unique identities that you can trust and you can pass it on to other entities on the supply chain that can use to first attest and authenticate the device, then do what they need to do. And essentially build this chain of trust with zero trust, which will help facilitate achieving IoT security. There are multiple things that are pushing for this. Moving forward in the next couple of years, regulations will play a huge role in how we do IoT security, especially around on the supply chain and building devices. There are many regulations out there, pretty much around, I think, like 30 countries are having their own initiatives around IoT security or supply chain security. These three are the most prominent one. European Union, the CRA, is the most technical one that we've seen. They're really getting into what hardware security your device needs to support, really getting to the cryptography aspect of it, getting to the secure element aspect of it, etc. And also they are the very first one that talking about bridging hardware and software security when it comes to connected devices. So it's not just either or, it needs to be both together. There are also other regulations that are sector specific. Automotive famously has a lot of safety and security functionalities around it for a couple of years now. Just a month or 2 months ago, FDA announced the new cybersecurity standards around medical devices, which also gets very technical as well. While these are very helpful to create a framework, to just create that picture that I showed in the previous slides, establish a chain of trust between people, help people to do to know what to do. But at the same time, one of the challenges for regulations is the confusion that they are creating on the ecosystem. Which one of these are you going to follow? If you're a manufacturer in Taiwan, you're building a medical device and you're shipping to Europe and to US. Are you going with the FDA one? Are you going with the US Cyber Trust Mark? Are you going with CRA? And these are challenging bits. And currently, I have not seen any kind of collaboration between these regions to come up with the same framework that everyone agrees, so the supply chain knows what to do and where to go. And the next couple of years, this is going to be very, very colorful and important. Moving on from regulation to the science, there are a lot of new things are happening in front of us. Quantum computing is one of those new scientific discoveries that is shaping the way we do security. And I'm sure you're aware from NIST standards, the PQC algorithms, post-quantum security algorithms that needs to be around in a year or two. And that will create a challenge for IoT devices, especially on the MCU market, kind of a lower end type IoT devices. How long will it take them to be able to support the PQC algorithm at the chip level and ship the new products out there? What's going to happen to the IoT devices out there with ECDSA, existing cryptographic algorithms that are not quantum secure? How are we going to transition those? Do we need to actually change the hardware? Are there middle ground that we don't need to change the hardware, but we can still trust the devices and trust the data coming from them? So we'll be going through in a couple of years of dealing with some challenges about transitioning to PQC world, but also dealing with legacy data that is already in the field. The other side of it is AI, which could be a double-edged sword, basically. Obviously, this morning, if you were at the keynote sessions, AI can have a lot of value from finding the vulnerabilities, whether it's a device behavior, to actually checking the codes for vulnerabilities and point out things that we cannot do today, and hence add a layer of security to what we do. But at the same time, it could be used by bad actors to look for vulnerability in our networks and in our device behavior, etc., in order to hack the systems. How are we going about to utilize them? And again, going through the transition would be interesting to see in coming years around IoT security. And then there are new frontiers, such as metaverse and areas that our real lives and our digital lives are converging, and pretty much all of those dependent are the devices that are empowering those new technologies. So how would you hack a casino in a metaverse world? Maybe, yeah. So about a year or 2 years ago, MGM got hacked in real world, not metaverse world, by the hackers impersonated one of the employees and managed to get access to the systems and steal a lot of data. Obviously, that was an impersonation in the real life of a person, has nothing to do with IoT. But when you go to these new worlds of metaverse, etc., everything becomes digital. How would you prove your identity in those worlds? And if you look at it, everything will boil down to the identity of your avatar, your personality, your company, your credit card, your bank, etc. And everything will be empowered by a device, which will be linked to how do you trust the device and the software that runs in it, or the identity of the device, essentially. So moving forward, we need to deal with a lot of new challenges and a lot of new threat vectors that are becoming imminent because of the new frontiers that are in front of us, new technologies. But the foundation of IoT security pretty much stays the same, and it will evolve around identity of the devices and how do we secure and how we trust the data, the device. And that is for me. Thanks very much.